All right, so on notes 2-2, we're going to be looking at logarithmic equations. There's going to be, this unit, there's going to be 3 different types of equations that we're going to be looking at. There's going to be some equations that have all log terms. There will be some that have some log terms. And then on the next notes, we're going to look at no log terms, which will be exponential equations. Okay, so those are the different types of equations that we're going to be looking at this unit. Now, first thing you need to do on these equations is you need to figure out, do you have all, do you have some, or do you have none? Okay, so that way you know exactly what you need to do. On today, we're only going to be looking at all or some. Okay, so what I mean by all or some, all means every single term has a log with it. Some, only one or more have a log, but the others do not. Okay, so we're solving each of the following equations. Looking at these examples today, where our goal is trying to solve for x and get rid of that log term. Okay, so we learned that on a log term, we could rewrite that as an exponential. Okay, so that's what we'll be using. On number 1, check to see if it's all logs or some logs. Notice it's some because the left side has a log, but the right side does not. So this would be some. If it is some, in order to get rid of the log, you're going to use around the world, which we talked about. So before you can use around the world, you have to have where it is one log that equals a non-log. And notice we already have that. Okay, so we're going to start out with changing it to exponential by using around the world. So our base is 3 squared equals 4x minus 7. So 3 squared is 9. And then we're solving, now we have a linear equation. So we're going to add 7. So that's going to be 16 equals 4x. So divide and x would equal 4. Now, on log equations, there are some times when there's extraneous solutions, which means it doesn't really work out. And those are the cases where we don't want our m term to be a negative. So once you have found your x, plug it back in. So plug it in there. 4 times 4 is 16 minus 7. When you plug it back in, make sure that it gives you a positive there. So that's really all you have to check for, is just making sure that it doesn't give you a negative in that spot. Okay? All right, so let's look at number 2. Notice we have a log term on the left side and a log term on the right side. So this is all logs. What you're trying to do is, we talked about yesterday that we had a log that equals another log. What we could do is just drop those logs and set the m equal to the n. So that's what we're going to do here. So make sure that you condense both sides, and then you can do m equals n. So just dropping your logs. That's what you're trying to do, is get rid of the logs on all these equations. So to condense, look at the left side. I need to move that coefficient and make it an exponent. We talked about that yesterday. Log base 5 of x squared equals log base 5 of 9. Okay, so notice we have log with base 5. Those are equal, which means this has to equal this. So x squared equals 9. To solve that, we can use the square root method. So we get x equals, remember, positive negative 3. But remember, I told you I wanted you to plug it back into the original. And if you plugged in the negative 3 for x, it would cause that to be a negative, and we can't have a negative in that position there. So you will only choose or write positive 3 for your solution there. Okay, let's look at number 3. So look to see if you have all or some. We have a log, and then we have a non-log. So this would be sum. So what I want to do is condense the log side. So looking at the left side, I want to condense that. So when I condense, I'm adding and the bases are the same. So when I condense into 1, I multiply them. So I should have log base 4 of x plus 3 times 2 minus x. I need to multiply those. That equals 1. Once I have condensed, then I'm using around the world to change it to exponential and get rid of the log term. So my base is 4 to the first power equals all of that multiplied together. I'm just going to rewrite that and then I'll multiply it. Okay, so 4 to the first power is just 4. I need to use FOIL here because I'm multiplying binomials together. So I'm going to get a 2x. That's going to be negative x squared plus 6 minus 3x. Okay, so notice now that I have a quadratic equation. I'm going to go ahead and combine like terms and put it in standard form. So I'm combining these x's here to get negative x. Okay, so we're solving a quadratic equation. We've learned several different methods. You can use quadratic formula, you can use completing the square, you can use square root method, which we can't on this one. You can plug in the calculator and graph it, or you can use your favorite, which is factoring. So that's what we're going to do. We're going to see if we can factor it. So if we are factoring it, remember we want that first term, which is our x squared term, to be positive. So that means I'm going to move all of the stuff on the right to the left side. So I'm going to add x squared, add x, and subtract 6. So all that now equals 0. So I have x squared plus x, and then that would give me minus 2. Okay, so let's see if we can factor it. So if we have 3 terms, check for GCF first. Notice we don't have a GCF, so we're doing sum and product. The sum would be positive 1, the product would be negative 2. So we're wanting to add to 1, multiply to negative 2. So that would be a positive 2 and a negative 1. So we factored it, but we're having to solve it, so we have to go another step. We're setting each factor equal to 0, so x would equal negative 2, and the other one, x would equal positive 1. Again, I told you when you're dealing with log equations, you need to plug it back in and see if, in the original, if it would cause that m or n to be negative. So look back. If I plug in a negative 2, that would be positive 1. If I plug in a negative 2 here, that's going to give me positive 4. So actually it gives me positives on both of those. If I plug in a 1, notice it'll give me a positive here, and it'll give me a positive there. So they actually both work. So make sure, you have to check and make sure it doesn't cause that m or n, which is the term after the base on a log. It has to be a positive there. Okay, so let's look at 4. Check and see if it's sum or all, because that's all we're looking at today. So we have a log, and we don't have a log, so this would be sum. So remember on sum, we're wanting to condense the log side. So I want to condense the left side. I'm adding and bases are the same, so I condense by multiplying. Log base 3, remember your base never changes, of x times x minus 6. Once I've condensed the log side, then we're using around the world to get rid of that log term. 3 cubed equals x times x minus 6. You could go ahead and distribute that if you wanted. So 3 cubed is not 3 times 3, it's 3 times 3 times 3, so that's 27 equals x squared when I distribute minus 6x. So notice again we have a quadratic equation that we're solving from here. So we need to set it equal to 0, choose whatever method you want. I'm going to factor or see if I can factor it. Notice my x squared term is positive, so I don't want to move that. I'm going to subtract 27. So I have 0 equals x squared minus 6x minus 27. So factoring it, GCF first, they don't have anything, so we do sum and product on 3 terms. Sum is negative 6, product is negative 27. So let's see, that would be negative 9 and positive 3. So we factored it, but we're not finished. We have to then set each factor equal to 0 to actually solve it. So x would equal 9 and negative 3. Okay, so again, plug those back into the original and make sure that it doesn't cause your m or n to be negative. If we plug in a 9, that's a 9 there, that would give me a 3. So that one works. So just checking for the negative. Plugging in the negative 3, that would be a negative 3 here and a negative 9 there. So that one does not work. We can't have that part to be a negative. So make sure that you're just checking to make sure that it's not a negative term once you plug it back in. Okay, so this was solving log equations with all and sum. Tomorrow we'll get into actually solving without a log, which is an exponential, and then we'll have to use the log to actually solve it. If you have any questions, make sure that you're coming in to get help.